Hey coding what? So basically today's GFG POTD we have a problem. Toeplitz matrix, and it is an easy kind of problem. And here the problem statement is given as Toeplitz matrix, also known as diagonal constant matrix, is a matrix in which every descending diagonal from left to right contains the same element. Given a rectangular matrix mat, determine whether it is a Toeplitz matrix or not. Implement the functions is Toeplitz mat that returns true if the matrix is Toeplitz matrix, false otherwise. So basically again problem, here we have a matrix, and here we can consider it as a Toeplitz matrix if their diagonal elements are like constant. Like for example, if I'm talking about the example one, here we have elements like 6, 7, 8, 4, 6, 4, 6, 7, 4, 6, 7 and 1, 4, 6. So if we are actually looking at the diagonal elements, so here we are having 6 as constant value for our diagonal element. So here we can select it is considered like Toeplitz because every diagonal elements from top left to a bottom right has the same elements, that means 6. And here expressions like also given here. For example, the main diagonal is 6, 6, 6, and other diagonals like 7, 7 and 4, 4 are also constant. So here we have to return true. And now if I'm talking about the second example here, so here we have 6, 9, 6. So it is returning false as the primary diagonal element of the given matrix has 6, 9, 6. As the diagonal elements are not same, so here in that case it is not considered to be like Toeplitz matrix, and here to just simply return false. Here we need to solve this problem with an expected time complexity of order of n and n cross m. Okay, and here we have to use here we don't have to use any extra space, so here we have to solve this problem with the space complexity of order of n 1, and this is like completely based on matrix and data structures. Okay, let's try to solve this problem here. So here what we have to, first of all we have to define the size of rows and column for the given matrix, as it is a two-dimensional matrix. So here int m is equal to mat dot size to find the size of rows. Okay, it will return the size of rows, and int n is equal to mat of 0 dot size, it will return the size of columns. Okay, now once we have like defined the size of rows and columns, now we need to check for the diagonal elements, that whether it consists of having the same elements or not in the diagonal element. So what we'll do, our approach is very simple. We have to traverse, starting traversing from first rows, that means not this row, this is considered like 0 row, then this is first row, then this is second row. So here we have to start from first row and first column, that means here we have to start from the middle of the diagonal element, and with the help of that we need to check its previous value, that means previous diagonal element's value, and the next right bottom right values. Okay, so here what I'm going to do, here I'm using nested for loop. That's why it takes the time complexity of n cross m. Okay, because we actually going to traverse first of all for rows and then columns. So here for int I is equal to 1, and then I is like less than m, then I plus plus. First of all we have to traverse inside the rows, and here we started traversing from this rows, that means our first row, and especially for column I am going to traverse for this first. So here I can say that for int j is equal to again 1, and j is like less than n, and then j plus plus. Now once we actually traversing in our both rows and columns, we need to give the conditions, and we know very well about how we can check the diagonal element. So if we have to check the diagonal element, we have to just simply pass if I is like equal to j, then it is considered like diagonal element. But here we don't have to check whether the diagonal elements is like they are not. Here we just simply check the previous value and the next value of the diagonal elements are like same or not. So in that case what I will do, here we just give the condition like whatever is the matrix of I and j, as I'm already standing at the middle of the diagonal element, that means I'm already at this point, I'm starting traversing from this point. So here I'm saying that if matrix of I and j is like equal to, I'm giving the condition, or like not equal to matrix of its previous diagonal element, and how I can reach to this place from this place. So for that, here we know very well about, here I'm standing at I and j, where I is like equal to 1 and j is like also equal to 1. So in that case what I will do here, for moving here I have to use I minus 1. Okay, I and then j minus 1. Okay, So in that case, how we can do, I will simply return false. Okay, okay, here to just do I minus 1 and j minus 1 for both the case. Okay, else we have to simply return true. Okay, that's all about this one. Let's try to compile and run. So yeah, here compilation is completed. Let's try to submit it. So yeah, it's submitted. So yeah, that's all for today. Thanks for watching.